There we go. Okay, cool. Hey everybody. My name is Riff. Riff, I don't really mind. Go with whatever. And welcome to this Studio's Twitch channel for this Tuesday evening stream. We're going to be streaming Shenzhen I by Zachtronics Games. I think that's the name. I don't know. And it's going to be a fun time. I gotta get a sip of water. Make sure my vocal cords stay nice and okay working. And that was a good pop. The main goal for the Disco Studios Twitch page in general is to play educational games and learn something from. And I think Zachtronics as a studio in general. Oh, hold up. There's an echo in my audio? Let me fix that real quick. Point that out, Dr. George. There we go. Does that fix it? I think that should fix it. I was listening to myself there for a second. It might have caused the audio. We'll find out. Okay, awesome. There we go. Good deal. I'm going to minimize the stream itself and just keep the Streamlabs bit open in the corner. In the meantime, let's get to it. So what is Shenzhen I? It is a game by Zachtronics. They've done a lot of games sort of in this puzzle, not puzzle genre, more like problem-solving genre. Their other most well-known one is Opus Magnum. That's a game all about like alchemy and such. But Shenzhen I is a game about microchips. It's a game about making microchips, making electronics, and making them to certain levels and capacities. It's not an educational game in the typical sense that it was designed by / for educators, but more in the way that it is a game designed around teaching you a skill in a way that is quite good, in my opinion. I haven't played it all the way through personally. I'm going into most of this blind, mind you, sort of show the learning experience as someone who's experiencing it. But the Zachtronics games I've played in the past absolutely tend to follow that, and I have no doubt this will follow suit. Everything I've read about it seems to indicate that. Now, we open up here, we have this button, which is the button that ends the game. We're not going to click that. That would be a bad idea. And then we also have, over here, we have concept mail. We'll get to that in a moment. We have the data sheets, which we'll also talk about. We have the control panel. Control panel is settings. If the sound is bad and I need to adjust it, let me know. This will be where I do it. The data sheets, that's a little PDF icon. You click that and it opens up your browser. And basically what it has is, hold up, give me a second. Let me fix that. Something's making noise, I think. Sorry, y'all, give me a hot second. Technical fun times. The beauties of streaming for the first couple times, I suppose. Okay, that should fix it. So, if you click that data sheets button right here, I was pointing at the screen, y'all can't see that. The data sheets button right here. It opens up a PDF in your web browser, and it's basically an instruction manual to most of the hardware that you interact with in this game, right? Now, instead of scrolling through a Google Chrome window off stream like on my second monitor where y'all can't see, I printed it out. We got all the data here. You want to know about electronics pieces? Boy howdy, you're gonna learn. We're all gonna learn about electronics pieces. It's gonna be great. So I'm gonna keep this thing handy, and in case we run into some issues, this will be the manual that we consult. Now let's get to the process of making microchips. The concept mail down here, I believe, is where we got to go to for that. It's our email. We have basically been employed at a company to make microchips. So welcome. This is a general email, I think, just giving us introducing the characters and such. I'm not going to go through and read all of them right now just because I want to get to the bit where we be learning about microchips and such. The advice, read the manual. Got that covered already. Manual's about to get read. Over time throughout this play session. There was a non-manual person who quit just before we started and whose name shall never be uttered again. That's either a funny joke or that's foreshadowing for like the final boss of the microchips game. We'll find out. So, step 1, fake security camera. This product is an imitation mock security camera. It has 2 blinking lights. The first light blinks in a regular pattern. The second light is an internet light, so it should be blinking in a more random intermittent pattern to resemble data upload. As you'll notice, the design is partially complete already. A previous engineer quit, before finishing the assignment. Note the timing diagrams in the verification tab. When you simulate, your output should match those expected values as indicated. Let the simulation run until it has passed all the test cases to make sure you have a proper solution. And Carl says, I'm absolutely sure you will do better than that last person. So we have a pretty low bar to beat here, dear viewers, at first. Also, if the sound is too loud, anything else, let me know. It's easy enough to adjust. I got Twitch Studio open. Should be fiddleable. So let's hit Open Concept CAD. Let's see what we got. Okay. We will create a working design, and it will show us the histograms and leaderboards. This is a trademark of a couple Zachtronics games. The other one, Opus Magnum, being the one here that comes to mind. But here we go. So, I am seeing this the first time as y'all are. This is pretty much a blind playthrough for me. I think I watched a playthrough of it a hot second ago, but I don't remember anything from it. So, what are we dealing with here? We have to make a fake surveillance camera. Like they said earlier, intermittent versus repeated stuff, right? Let me turn down the game volume just a tad bit, just in case. Because it's a bit loud on my end, so I can only imagine it's bad for y'all too. Let's see. How's that for y'all? It's a bit loud for me, actually, personally. Let me adjust that real quick for myself. Music volume down to here. Okay, hopefully that'll adjust it for y'all too. Back to work. So, this is what we got to do, and these are the verification. This is the verification we need to do. We have the active one, which is a simple output of on-off intermittently, and then we have the network output one, which looks intermittent, but it's still kind of normal. So we have one piece here, the MC4000. It is, I believe, a microchip of some sort. We'll pop open the instruction manual in a moment to see what that's all about. So this guy says, why is this so hard? Which, you should have read the manual. That's the problem. I guess that's the first thing we learned from this game, is that you should read the manual. It's good advice. It's good advice generally. Let's just hit simulate and see what it does. Okay, so I think this one's already working. Let's see. Simulate on, off, on, off, on. Okay, so it looks like active over here is working properly already. So we don't need to worry about that. We just need to worry about network. Let's see. Now, inside the manual, the front page has a language reference card that they ask you to sort of tape or store somehow. And it has all the basic code instructions. I don't think we'll need that a ton yet. Hopefully, we'll see. But let's see. We will basically go through all of this, and it will be that'll be the game. So, I don't think we need any manual info yet necessarily, but we can take another MC4000 and toss it in here. Now, if we click in here, we can type in code. Right. Disco Tray Studios. Oh, I can only do the DST exclamation mark. Let's go with that. It's either Disco Tree Studios or some sort of destination, one or the other. Future coders can figure that one out. That's a mystery for them to solve. So then we have here this random light. So it looks like there are these time chunks. I think they're part of a second each, obviously, but I don't know the exact amount. It doesn't really matter. It looks like that it says 0, 0. Okay, so P0 is one output. We have X0 as the other one, I'd assume. And we can set P0 to 0 or to 100, right? Just like we have 0 and 100 here. Reminds me a bit of some Arduino code, actually. It's also actually similar to an earlier Zachtronics game where you had to control... Ooh, that's fun. Where you had to control an entire fake operating system, but that's over my head too, honestly. So let's make this simple. We have 1, 2, 3, 4. So it should be MOV 0, P0. Oh, enter. Oh, yeah, we should probably connect the pin too. That might be helpful. But can we connect it there? Okay, hold up. How do I get rid? There we go. So I could make this pin layout very silly. I'm sure that that'll come into play later, the space of all the pins and such. Okay, move 0P0, SLP4, let's call it, right? Let's see how that works. Okay, so it got there, but it didn't do anything, so we got to add a second step here. And now, folks, this is one of those games where I'm sure that you guys will see some answers before me. So feel free to chime in the stream chat if you have any ideas for some of the later puzzles. I'm going to be playing this game going to be playing through most of it, hopefully, over the next couple weeks, and we can sort of solve it together. We can all learn about coding as a community, I suppose. So MOV 100 P0, right? And that goes for 2, so we say SLP2. Let's see if that works. Oh, that did work, but it stuck at 0 for the rest of the time, so that's going to have to loop properly eventually. Then we say move, or MOV, I don't know what that stands for. It's probably in the manual somewhere. MOV 0 P0, SLP1, MOV 100 P0, SLP1. So the reason I'm saying that is because it goes, this first command sets it at a certain value, and the second command would tell us to basically wait some amount of time. Let's see if that works. Okay, we're good. Oh, okay, we got a thank you chip over there in the corner, giving us the chips tips. We've successfully completed one test run, and so we're just letting it run. Okay, so we have here at the end of this mission, or I guess assignment, as with all of the rest of them, we're going to have a production cost showing how much it cost us with all the pieces we put in to make it, how much power it used, which I'm not sure how that's tracked, and how many lines of code it used. So I think power might have to do with the amount of wiring. That would make sense. Maybe that also is cost. And then lines of code, it's pretty simple, but someone else has figured out some crazy tricks with maybe some later commands that we don't have yet. Maybe we can come back to this one at the very end and see if we've learned anything new. Okay, return to email. We did it. Thanks for your prompt work on the blinking lights. Looks okay. Thank you, boss. Okay, let's see. This is plot stuff. We can toss all. I can reread the plot stuff and give you all a summary later at some point. But let's work on the puzzle bits. So next up, we got uh-oh, something got broken. We're gonna have to fix a signal amplifier because something went wrong in some controls. Uh-oh, that'll be interesting. Something stuck in my nose. Let's open it up. Let's see what we got. 0 parts, new design. Let's get to it. So, control in is a simple input connected to factory equipment. Control out is a simple output connected to other factory equipment. The signal from control in should be multiplied by 2 and copied to control out. Okay. We gotta figure out how to do math now. Oh, my least favorite part of computers, the math part. Yeah, not a fan, not a fan. How do I drag it? There we go. So, we have control in and control out. Now, I'm not quite sure if there's a way to change, because I think these are the outputs, but it could be these bottom ones that I'm not sure. That sounds like a thing to consult the manual about. I'm not quite sure which is the input and which is the output. Let's see. Do we know? There's a bit later on where they list off all the different microchips and what they all do. Well, there is one register, the ACC over there. It's or ACK. It's one register, and it can store a value. We can say, hey, store this value in there. Then we can do math on it. And I'm guessing what we'll want to do is get the input, multiply it, and output it, and then rinse and repeat. The question is, how do we do that? Okay. So, So it's looking like P1 and P0 are going to be the input and output. The P pins are going to be the input and output ones. I'll have to look up the command for outputting a thing in a moment, but that seems to be the general vibe of it. So let's just get the wiring out of the way first, folks, since we already know what that's going to have to be. Control in heads over here. Control out heads over here. That doesn't look nice. Let's make it symmetrical. There we go. Nice and pretty. I don't. Is there a way to rotate these? No. Okay. We could just have some fun and just put a bunch of wiring around here. Just short out the whole circuit. There we go. Don't do that. Actually, that's a bad idea. So I guess step one. Okay. Move the value of the first operand to the second operand. So MOV, the command we used last time, basically moved a value to a thing, right? So I'm going to try something. I'm going to see if we can do MOV to ACK. See if that does anything. Okay. Something did something. Got it. Oh, the part isn't sleeping. It's using power forever. That's bad. No, let's not do that. Uh-oh, I made it use infinite power. Let's reset that. So we can move values to ACK. That's interesting. Let's see if we can do this. Move P0, ACK, and then sleep 1. There we go. So it doesn't run forever. SLP. Okay, so it's writing the values. Good. Okay, we can work with that. So we don't want it to sleep and just do nothing. We want it to multiply it out. So multiply command MUL just takes a value, and I think it just multiplies the multiplies whatever's in there. So do a step. So this outputs 25, right? And it takes it. It takes it and it stores it into ACK, and then it multiplies it by 2, which makes it into 50, and then it goes to sleep once. And then 0, 0, 50 to 100. Got it. Okay, so that seems to be working because ACK is being multiplied by 2. Let's reset. Also, can we move this around with the? Oh no, the wires don't like that. So I guess the next step is MOV ACK P1, right? Take the stuff we're storing and toss it out. Let's see if that works. Up 50. That's what we want. Yes. Let's just advance and simulate it. And looks like it's working. What does the profiler do? Oh, that's what it does. Okay. I'm sure that'll get more complicated later. Okay, so it looks like we got it. There's probably a better way to do that now that I think about it. ACK probably wasn't necessary. You could have just said, I don't know. Because I'm seeing one person over here did it with less power usage via magic, I guess, because I don't see how you could have done that simpler. Return to email, though. That's a good one. Looks good, thank you. Take care, yeah, cool. Oh, we got 2 new ones, but let's do please enjoy a game first. I need to win a game of solitaire. Okay, so here we have Solitaire, which much like Opus Magnum, which was Zachtronic's previous game that had like another sort of mini game that it did every once in a while. This is not programming stuff, I don't believe. Let's see if we go back to home. Yep, there's the Solitaire thing. We don't need to mess with that. I'll do the Solitaire in my free time, maybe. Depending on how fun it is, I'll try it out once or twice. But I'm going to try to do all the main missions live on air. Let's try the pulse generator next. Solitaire, no thank you. Let's see, create a working design. So we need to make a pulse generator. However, instead of buying one at market price, we're going to make our own. A smart choice, you got the electronics, so you may as well. We must make use of conditional execution. Oh dear. We're going to use like if statements. Okay, so the button is a simple input. Button's over here. It's a simple input connected to a button. Makes sense. Pulse is a simple output connected to a device. As indicated in the verification tab, button being pushed will generate pulses until button is released. Okay. Note. Just Trey Studios. Hey, Raider. Hold up. I have an idea. Let's go. Let's go. Trey Studios. There we go. Now we're in it, folks. Now we got a little copyright. No, we got a little signature here. I like signature better. It sounds less corporate than copyright. Less boring. So, when button is pressed, we want it to go beep, 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 beep on the pulses. That probably sounded awful on y'all's speakers. I am so sorry. So we have a bridge. What does this do? Oh, it lets us do this. I have a feeling this is not going to work. Let's find out. Yep, that didn't work, but we know how the bridge works now. It takes the wire, it transfers it over, like the power. Let's remove that. We do not need that. I'm glad that notes don't cost us any money. That would be bad and very disappointing to me. So, we have the M600 or 6000 and the M4000. The M6000 costs a bit more, but it looks like it does some more fancy stuff. Let's see what it does. It has AC and it has DAT. So if we go over here, I got the manual out, printed out. So it looks like it has two general purpose registers. AC and DAT are both registers. DAT is not used for arithmetic instructions, but AC is what's targeted there. So we're going to have to figure out some way to make this work. My guess is we could maybe make some sort of count in AC that notes what phase of the thing it's on, or maybe like what the last thing was. Like make it do the opposite of last time, unless the button isn't pushed, in which case, don't do anything. The only question then is, how the heck do I do if else, etc.? Test instructions. Getting some water, gotta stay hydrated, folks, especially nowadays in Texas and Arkansas and elsewhere too. Water's important. It's 70% of you. So, they talk about conditional execution. Here we go. All instructions are capable of conditional execution. Prefixing it with a plus or minus will cause that instruction to be enabled or disabled by test instructions. I'm not quite sure what that is. It will be skipped and not consume power. That's good. We wanna limit power whenever we're making these things. All conditional instructions start in a disabled state. A test instruction must be executed to enable conditional instructions. Just put a plus or minus up front. Well, how do we get okay, test instructions. Okay, so it looks like anything with a plus after a conditional is basically do that if the conditional is true, and anything with a minus is do it if it's not. Let's write a bit of code just to figure out what that is. Let's see, plus mov 1000. So if whatever we were about to do is true, then 1000. Oh, it's too big. Yeah, we can only go up to 999. I forgot to mention that. Let's say on the 1. Bit underwhelming, honestly, y'all, but yeah. Then, if we have a test instruction, let's see what that does. Test EQ, TEQ, 1, 2. So our 1 and 2 equal to each other. Now, I've done comp sci for so long that I forgot how basic math works, so I'm not quite sure. Hopefully we'll find out. TEQ, 1, 2. Okay. Raider, this is, it's for Disco Trace Studios, which is technically registered as a class, but it's like an organization thing that is sort of a bunch of Hendrix coders working on projects for community stuff. But also, I have fun doing this, so a little bit of both. Godrich, I think, is still in the chat and should be able to give you a bit more info. If you're curious, check out our website. I think it's just discotracestudios.github.io, but I might be wrong. I think it's on the Twitch channel if you want to check out the website itself and see exactly what we're doing. So it looks like, yeah, TEQ is oh, we're just using power forever. Okay, yeah. Now if we do TEQ 1, 1, let's see what happens. Step, okay. And it sets ACT to 1. Got it. Okay, so I guess that's how conditionals work here. That's weird. I haven't done anything like that before. Not exactly, at least. Kind of, but not exactly. So, what we want to do first is hook up button to P0 and hook up pulse to P1. I think that's the best way to do it. I don't know why they gave us the bridge already. That feels like it's going to use more wiring, maybe? I'm not. I want to do something fancy with the bridge. Sorry, y'all. I know this is probably inefficient, but I don't care. It'll be fun. And that's what it's all about, honestly. Oh, nope. Got it. P1. Can I rotate this? No, I can't. Oh well. That's a shame. Oh, let's waste it even more. There we go. Nice and wasteful. Look at how that doesn't need to exist. So let's say TEQ P0. So if P0, the button, is 1. Bit of a strong reaction to the bad wiring ethics, Raider, but thank you very much. So if P0 is 1, if we're getting input, right? I think it's 100, not 1. Yeah, if it's 100, then we want to be doing the pulse thing, right? So how do we make that work? I guess the first thing to do is let's just make it output a normal pulse, and then we can make it worry about the rest of it later. So TEQ, and we want it to go on for 1, right? So let's just make ACK represent if we did a thing, right? TEQ 0 ACK, right? So if ACK isn't, if it's 0, then whatever we're about to do that. Otherwise, do something else, right? So if it's 0, first of all, mob 1 ACK, right? So first of all, set ACK to 1, then mob P1 or 1 P1. Then, and if it is, okay, so if so that's what will happen if it's 0, right? If it's 1, then we should set it back to 0. So mob 0 P1 and mob 0. Got it. And then still P1, so go to sleep once. So let's just simulate it. Huh. That is bizarre. Step, 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 step. So it's not, 1 and 0 needs to be 100. I keep on forgetting that we're outputting 100. I'm just gonna make them all 100s, honestly. And 100 is true now, I guess. Let's see. Okay, yep, and we can see it's going. Now it's going in reverse of what it should be. It should be starting out at flat. So let's do this. 1. TQ is 1. Then we should 0. This is actually probably bad. There we go. Well, I'll fiddle with it in a second. But that's generally how we want it to work. So how do we make sure that it only does that when the button is pushed? I guess, I know what we can do. So we've been moving 100 to P1. But if button, right, we know button is let's see. Button is outputting 100, right? So we can just say set button to pulse every once in a while, as long as button is around. Now I don't think we should have that going constantly, just because that requires it to be at certain intervals, as opposed to just starting the moment you press the button, which is what we want. And that could be unreliable if they put an odd number of spaces, which I don't think. Yeah, they have here. There's a 5 and a 3, and that'll mess up the thing. So with that in mind, let us say, I guess if we can do this with the M4000, we should do that. But let's try with the 6000 first, and we can copy over the code in the moment if we need to. Then we can just copy it over. That's possible. So, hello. So, welcome. We're playing through Shenzhen I. We're going to be making microchips. Welcome to Disco Trace Studios. It's me, Griff. We're streaming a couple times a week. I think there's a full schedule, but Tuesdays are my evening. I'm going to be playing through this game the next couple weeks, learning about microchips and how you code them. Or generally, this isn't a literal one. This is a fictionalized, but the same concepts. Enjoy your stay. If you have any ideas, advice, etc. on the game, feel free to post in chat. This is a team effort. We're not at the tough stuff yet, I don't think, but we'll get there, I'm sure. Well, welcome aboard. So, GQ1 PO. Got it. So, only do the following things if PO is pressed, right? We should also, like, So the challenge is I'm trying to figure out a nice, clean way to do this, and without, like, multi-layered division, it doesn't work, which is annoying, but that's microchips for you. There are limitations. A thing I've already learned from this game. What do you know? Here we are. So, I guess ACK can be our timer. That sounds good. So, we have not gotten to the secret instructions yet. This is problem number 3. We are very early on in it. We're already half an hour in it. Frankly, it's taken me a lot longer on these than I thought it would. So, but the instructions I do have are the manual. I've printed that out yet. I'm curious about those instructions, though. Looking forward to learning about those eventually. That'll be interesting. So let's set. Oh, my camera's wiggling. Oops, I bumped my table. Sorry about that. Move 1 to ACK. So, if it's true, then we can have ACK be our timer, I guess. Well, no, we don't want that necessarily, do we? Raider, you make a good point. I should just solve it. I'm gonna do the thing I was thinking of earlier, where it just sets it equal to the output, but that might be a bad idea. We'll find out. It'll be a fun, interesting little puzzle for us. So, yes, if that is the case, mov p0. Oh, I don't need a timer. Interesting that you should say that. I am afraid to find out what that means, but I'm sure I will figure it out either very soon or it will take a while and I'll be tearing my hair out, which honestly will be very funny. Oh, I'm using infinite power. Let's not do that. Also, SLP1. Okay. Oh, I'm dumb. It's 100. I always forget that it outputs at 100 instead of 1 because use decimals. Hate this. Okay. Yeah. Okay. Well, this is bizarre. Why is it doing that? That shouldn't, unless I'm missing something. Oh, I see how it is. Okay. Okay, it's just skipping them now, which is odd. Shouldn't be doing that. I think, I guess the other way to do this is instead have it say, like, a thing that says, did we press it last time? Like, last loop, and if we didn't, like, don't output it, right? And if we did, output what we got last time. And then I guess reset that counter whenever you press the thing. Let's try that. So I guess we We actually don't even need all this. I just realized that. We can just do this with one. Sorry, Raider, I know you're a big fan of the terrible wiring. I'm going to have to make it even worse now. Hold up. Move this up here. There we go. That looks terrible. Hate that. I'm streaming. I need to say things. That's how it works. Sorry. So, say put 0 on negative. So Bahamut, do you mean like put 0 output on the negative? Because I can see that. I'm just making sure that I get what I'm picking up what you're putting down. We'll find out in a second. There's a stream delay. Raider, you're really just dunking on me with these, aren't you? Dang, I'm kind of hurt. Dang, I'm gonna cry now. You're gonna get me to cry live on stream. That's what you're gonna do. SMH my head. Can't believe this. So, you know, fair enough. We need to figure out some emotes for this channel too. So if anybody has ideas, well, contact us on Twitter or our website or on here, and we will consider your emote ideas, as long as they're like good ideas, please. Thank you. So let's see. If the button's being pressed, right? Twitch Prime indeed. Move 0, 2, 1 on the minus of. Right, so if the thing isn't happening, don't output. That I get. My confusion is how do I make sure the pulse happens? Because it's not just mimic the input, right? It's mimic the input. Tick tock, tick tock, tick tock. Which is where you got to store if you did it last time, I'd assume. So TQ, well, first, yeah, I guess, let's see, TQ at 100. If so, this isn't gonna work. I just want to see how it doesn't work so I can make sure I know make sure I'm understanding the coding correctly. Because also this is technically a new language for me. Mov ac. Yeah, I could just sleep twice, couldn't I? I forgot sleep is a command. I'm mad peeved at myself. Already missing things, folks. Already missing things. Sleep is... I can just wait more than one tick. That's an option here. Duh. So, we're learning. Thank you, Bahamut. You are far cleverer than I, even though, quite frankly, for problem number 3, the bar is very low. And yet, you beat it. Hats off to you, man. Hats off to you. I have none right now, and I can't take off the headphones. Otherwise, bad things happen to me, like physically. But, thank you. Don't ask about the headphones thing. I don't have time to get into it. TQ. So, if the button's pressed, yeah, P0, 100. Let's see. No. 100. P0 plus sleep 2. Or it said 2 and I typed in 1. Yikes. Oh, SLP. Let me write out the full words, cowards. Fair enough. Hey, listen. This is a game where I'm supposed to learn things, and I'm learning from the viewers. It's a community thing, too. So sleep 2, and then minus my... Why do I keep on hitting shift on the minus key? That's how you get underscore. Duh. I guess if that hasn't happened, whatever, right? Fair enough. So, yeah, if 100, oh, it should be sleep 1, then plus 0, be 0. And then, yeah, if not, okay. Now this isn't working, which I thought it would, which means I've missed something here. Oh, I'm sending it back at the original. I should maybe put the output pin to be the output. Who'd have thought? Okay, well now the problem is that it's stuck, so I need to move this to 2? No, that also doesn't fix it. Yeah. Okay, then it waits. Oh, I also need to do the sleep one there too, yeah. Duh. Oh, sleep, yes, sleep 0. Sleep 0, perfect, wow. Wow, I can't believe I gave it college brain. Sleep for 0 time. There we go. Finally. Took way longer than it should have, folks. Way longer than it should have. It's probably more optimized than the original solution was supposed to be, but I'm not complaining. Actually, it didn't use the minimum lines of code, so how good can it be? The fact that someone managed this with 2 lines of code, or maybe 3, boggles the mind. Raider, you really are going ham with the Twitch Prime, huh? Okay, we did it. Looks okay, suitable for our purposes. Take an orbital selfie, no thank you. Light up signs and other stuff. Let's see what we gotta do here. Let's find out. Click 0 and click 1 are simple outputs. Beeping machine do go brr, but my brain doesn't. My brain very much didn't. I need to make the chat window bigger, the text smaller, so y'all can get more words in there. So, if you click things, drink 1, drinks 2, and drink. Okay, these are all corresponding. Control the segments displaying signals. Okay, so yeah, we have the lights over here. This just feels like a bunch of sleep commands, honestly. This is what this feels like. It feels like we're just doing a bunch of sleep commands in a row. Which means, ideally, we would just have one microchip with a bunch of outputs, which I don't think we have yet. I don't even know what that is. I'm not touching that. I'm leaving that be. No thank you. I'm done. Not touching. I see logic gates, and that is going to be... We're not getting to that tonight. Too tired for that right now. I'm not going to do the Disco Trade Studios thing again. Y'all know where you are. You've seen the video. So, we have click 0. These are all outputs. All we got to do is make this work in rhythm. Okay. This seems very easy. I'm sure that there's an optimization way to do this, or an optimizable way to... Wait, this... Bahamut, you say this one... You say 2 lines. Do you mean the last one or this one? Because I can't imagine doing this one in 2 lines. That seems quite difficult. Is that compatible? I'm not. We don't need that many. We have 3 outputs. There we go. Let me drag it from the edge. 3 outputs, which means we gotta have... Or 5 outputs, which means we unfortunately are gonna have a suboptimal number of things. Now we get into the wiring issue, I think, actually, which is an interesting aspect I didn't expect to get into. Okay. Well, Bahamut, don't... I'm not going to ask for spoilers on how you figured out how to do it optimally, so I won't... 3 lines of code total? Secret instructions, I'm assuming, right? My brain is not there yet, unfortunately. My apologies. My folks are going to be watching this like, yeah, wow, the college education's paying off and you can't make a blinking sign. Okay. There we go. This is probably how you're supposed to do it at first, before you learn the good instructions. So we're going to go with that. I'm sure that my suboptimal solution was all part of the designer's plan. That's the excuse I'll tell myself when I look at the number being bad. Can, however, make these wires look good. Ah, gates. Yeah, gates would be helpful here, perhaps. Oh, no. There we go. Oh, let's see. I just want to get really clever with the wiring because I think the wiring is pretty. Oh, take that to P1. And then take this here. There we go. That down there. Got it. And so this one will control P0 and 2. Or drink 0 and 2. And this one will control these clicks. And we got P1 here. So these need to be just the opposites of each other. So mauve 0 or mauve 100 P0 mauve 0 P1 mauve sleep 1 SLP 1. There we go. Mauve 0 P0 mauve 100 P1 slip 1. Let's see if this works like I think it should. Okay. They're fine. Very rapid finger tapping. Just like you're playing drums or something with your fingers. Got a drumming bar, I suppose. So we have to drink 0. It's on for 1, 2, 3, 4, 5, 6 steps. So, well, now we have a problem because the timings are different. Yeah, we can't. I'm gonna be big lazy and big inefficient and make them all separate chips, even though I'm sure there's a way to do the timing better. Folks, I just don't want to, and that's the way it is. Oh, we can't connect that pin that far out. Truly, this is the Minecraft of coding, by the way, folks. I'd like to get that out there. This is the Minecraft of coding. In case it wasn't obvious. Yeah, these don't all work on the same rhythm. I don't think they all work on separate rhythms, so we'll have to get creative and or suboptimal, more likely. So next up is drink 1, which we can put here. P1. Then we can put this one here, and then actually that's not terrible. It's not great, but it's not terrible. Can't move this down at all. Yeah, no, you can't move it down at all. You could, actually. Hold up. I'm spending more time on wire optimization than I am on, like, the actual code, which is probably, in some ways, antithetical to what the game is going for here, but whatever. Yeah, I don't worry about that right now. We have enough to worry about already with this code. And then, there we go. Got it. So, we have the top one working. We got a mauve. This is the first one. Mauve 100. How long? 1, 2, 3, 4, 5, 6. Okay, P1. So P6. Then we rest for 4. Mauve 0, P1. So P4. Let's see if that works. Okay, got it. That works. Perfect. Okay. Mauve 0, P1, SLP 6. Mauve 100, P1, SLP 1. Mauve 0, P1. By the way, y'all, if y'all are just joining us, I saw we got a few new viewers. We're playing Shenzhen I today. It's a game about making microchips. Right now we're trying to get this little sign to be working. We've basically been hired by a company in Shenzhen, and we are making microchips for them, as I just indicated from the previous description. Bit redundant there. Sorry. Um, we're 2/3 of the way done with this, I think. Hopefully, unless there's like a secret second half to the sign where it unfolds and we gotta add more stuff, which we'll see. Oh, it was the same solution, but I'm gonna take that as a good thing because you seem to know what you're doing here. So, fair enough. So, yeah, 0p1, it's off. SLP2, mov 100 p1, SLP1. There we go. Let's see if that works. Oh, the timing is off. Why did I say 4? It's very obviously not 4, it's 6, the boy. Okay, that's partially working. Now we have just the last one to do. Reset. We're making this one sleep for 1, 2, 3, 4, 5, 6, 7. SLP 7. I'm assuming there are ways to optimize. It's a Zachtronics game, that tends to happen. Mod 0, P1. Oh, P0. Yeah, remove P0 this time. Mod 100, P0, SLP 1. Oh, something didn't work. What did I miss here? Oh, should make it wait for 2. Duh. My greatest weakness, as with real code, is not knowing basic numbers. Arithmetic. I have the computers do it usually, don't blame me. Oh, timing's terrible. Oh, yeah. Oh, no. Okay. The problem is there's a backswing now, if that makes sense. Mov 0, P0, SLP. This is suboptimal, but I think it works. Okay. Yeah. Make this go fast. Oh, this speed makes far more sense for the tapping actually too. Okay, I think that's it, folks. Let's oh, test run 3 out of 80 it says. Oh, it ran them all, and production cost far too high, which means that, folks, we probably could have used a few less microchips on that one, but oh well, I'm vibing. It's probably a way to toss something into a register there to tell us, like to, you know, have it do multiple levels. And also, we are above the normal lines of code. Now, what interests me here, ooh, bit of the water there. What interests me here is we have one bump here at around 22 lines of code, another bump down here, which makes me think there's some other general type of solution around this length, which is always neat. Zachtronics games do that sort of stuff. Honestly, I'm thinking of going. Thank you, Muhammad. I'm thinking of going back to some of these missions later, as like maybe, you know, after we beat the main game, maybe going back and like figure out how to optimize things. The results look great. Okay. Oh! The Solid Steel Gamer's clicking a mouse button. That's what it is, not just tapping a table. That makes way more sense. Okay. Got it. I think this might have to be our last one, and we're going to go a bit over the hour, but, oh well. It's fun, and y'all have been really helpful so far, and everyone seems to be having a fun time, so why not, right? Let's see. Point and fell are simple inputs. Displays and X bus displays. Oh, we're going to have to work with bus displays. Okay, that's going to be interesting. Counter should keep track of count starting at 0. Okay. Counter should always keep track of a count. So we have a bus now, which I think we can work with here with these. We could say this, right? This is the wiring, I'm guessing. That makes the most sense. Feels like it. There's a way to make it simpler, but I don't want to, so I'm not gonna. Just Google it, Beaumont. I'm being sarcastic. I would. Part of the fun of these games is figuring out yourself. But Let's see. So I'm not quite sure how XBus stuff works. What is the... Let's see if they got to explain it somewhere in the manual that I printed out here. Oh, here, folks. I bumped my mouse there for a second. Also, the pseudo green screening is looking weird on my... Raider, just because you buy all the emotes doesn't mean you need an excuse to use all of them all the time. I'm sorry. I don't mean to be, like, hostile to the viewership, but, like... Don't be rude and silly. Mostly don't be silly. I can take rude, but silly, not in this. Okay, now you're just going to spam a bunch, right? Oh boy. I don't know what I expected. I'm currently looking through, see if I can find where they talk about X buses. They've got to talk about it here somewhere. But, let's see, base constructions, instructional operands, registers. Let's see. So, maybe the X bus pins. Here we go. Got it. XBus pins. They're discrete. XBus values are discrete data packets from -9999 to +9999 inclusive. They are marked by a yellow dot. They are typically used to transmit data, such as a keypad or numeric display. Okay, so they're just input-output stuff with a different name. It does different stuff. That's pretty simple. The real question now is, what numbers do we send to the LCD screen? I think they mention it in the information section. LCD screen. So I have, again, the parts list up here, which means that they should list the LCD screen somewhere, possibly in like the third-party section. There's also like lore to it that I'll probably read through a bit myself later and update y'all on. But actually, it probably just needs to send them the number. Now that I think about it, way simpler than I thought it was. Let's do that. So let's see. First question, if ACK is less than 0, then set it to 0. That seems simple enough. I'm going to do that right now. I should probably run it at the very end, too. Okay. They're red once, and they range. Okay, got it. So we send... Bahamut, correct me if I'm wrong here, we send a number signal, and that number will be displayed, right? It's not like we have to send in the binary of which bits of the LCD to light up, because that... I'm assuming it's not that. Fingers crossed. Let's see. So, first value is... Oh, yeah, good point. It is 0 to the TLT if it first value is less than the second. So if ACK is less than 0, ACK or MOV. Okay. Have that running at the end. Turn it to 0 if it's less. It's not that hard yet. You say that, but my brain's already struggling. It's already struggled. It's already the struggle zone for my brain. I'm sure it will not get too much worse, but also, no guarantees either way. So, TLT ACK. Okay. If we have P1, if a point is scored, right? Which I'm guessing we're not going to get both at the same time. That doesn't seem to make sense. 100 plus. Also, let's just put sleep 1 at the end. Just because we'll need to anyways. Also, MOV ACK. Got it. P1 100. If it's 100, then add 1 to ACK. So we do add 1. Got it. TQ P0 100. If it's a foul. Raider, I'm not a gamer, I'm just a programmer helping other people play games, and that's just how it is. That's what we're doing here in Shenzhen I for Disco Tray Studios. Sub 1 or 2. There we go. So we haven't done multiple conditionals in a row. Let's see how they work. I'm sure it'll all go swimmingly fine. Oh? Did I get this first try? No, Raider, I know I haven't. I've dunked on your emote spam before, but now would be the time to go hog wild with it. Oh, and it looks like we are just about average. With power usage, I'm sure there was a way to save code or something there, maybe memory or something. Okay, we did it. Okay. Rubbish audio thing. Okay, I think we're going to cut it there for the evening, folks. Thank you for joining me on the inaugural stream of mine personally. This isn't the only one, obviously. It's happened so far here on the channel. If y'all are curious on seeing more folks that are part of Disco Tray Studios playing their own learning games, check out the videos. They should be on the channel, or tune in based on the schedule. I think that's on the channel description too. We might make a fun little visual for it at some point. We'll see. Otherwise, thank y'all very much, and I'll see y'all next Tuesday around 6 again, or 6 Central Time. Goodbye. This is a screen I made. I don't know why I made this. I was having fun with Twitch chat. Goodbye. See y'all later.